So, Ujwala, what did you get for this one? Did you get left, right, or two-tailed? Ujwala?
Mu greater than 43.
Yeah.
If it is greater than, then it's right tail.
Excellent. So because it's greater than 43, it's right-tailed. Good. Yep.
Yeah.
Perfect. Eno?
If it is less than.
Yeah. No, that's good. I'm going to ask somebody else the next one. So Eno, this one over here, is this going to be left, right, or two-tailed? Eno, are you there? If you don't have a microphone that works, you can just type it into the chat. That's okay too. All right, how about Angel? Can you give me this one?
I said that was left tail.
Oh, I'm sorry. Yeah, it is left-tailed. Right, because it's less than. U is less than 26, so it's left-tailed. Great. Michael, what did you get for this one over here? Bottom lower corner. Michael, you still with us?
You put a top.
Oh,
You said both.
both. Yep. So it's two-tailed. Right. So this one would be two-tailed. Great. And then, Allie, can you chat and tell us what this last one is? And can someone read the chat since I'm frozen?
She put left.
Yep. Perfect. Left-tailed. Excellent. Good. Cool. The rare event rule. So this is, in other words, if we get a sample and the probability of getting that sample is really small, for example, the probability of getting 6 red cards in a row is really small, then we assume that our assumption that whatever we assumed, in this case we assumed our deck had half red cards, half black cards, then we assume that that assumption was wrong, right? Because if the deck is half red cards, half black cards, then getting 6 red cards in a row is really unusual. If the deck is entirely red cards, then it's not at all unusual to get 6 red cards. But if we assume our deck is half red, half black, then the probability of getting 6 red in a row is unusual. So in this case, we would say that, oh, that assumption was incorrect. Your deck was not half red, half black. In other words, if we get something that is unlikely or unusual, then our assumption H naught is wrong, and this is when we reject H naught. So here we would reject H naught. Okay. So we're going to go through an example now. Sorry, we're going to talk about the steps. So here, first thing you want to do is write your claim using greater than, less than, equal to, or not equal to. So figure out what your claim is. So, and use these symbols, one of these symbols, like my mean is equal to, or greater than, or less than the regular, than U naught. This would be one example, right? And then write down what H naught is. H naught is always, always, always no difference. No difference. No difference means equal. So it's either going to be, this is the top of your notes. We are at the top of page 10. So it's always going to be P equals something. Don't fill in the blank. The blank is supposed to be a blank. Which means P equals something or mu equals something. But it's always going to be equals. Always H naught. And then here's the tricky part. You guys focus for the next 2 minutes. If your claim includes equals, then H naught is your claim, and H1 is the complement. In other words, it would be not equal to. However, if your claim does not include equals, if it's greater than, less than, or not equal to, then H1 is whatever your claim is. It's a little bit tricky, so I'm going to give you some examples, and that'll make it clearer. So here, Jay, can you go ahead and read this for me?
Situation A. A medical researcher is interested in finding out whether a new medication will have any undesirable side effects. The researcher is particularly concerned with the pulse rate of the patients who take the medication. Will the pulse rate increase, decrease, or remain unchanged after a patient takes the medication? The researcher knows that the mean pulse rate for the population under study is 82 beats per minute.
Great. So,
Okay.
you guys, okay, hold up, thank you, that's good. So you guys are the medical researcher. You want to know whether this medication has undesirable side effects, has bad side effects. So what do you want this pulse rate to do? Do you want it to remain unchanged? Do you guys understand what I'm saying? You want there to not be side effects, like your pulse rate going up or dropping. So what's your claim? What are you hoping? Anyone?
Yeah, that means there will be H1, that is alternative hypothesis.
No, what's my claim? No, I'm not talking about H1 or H0. What's my claim? What's he hoping for? That the pulse rate does what?
That the pulse rate stays the same.
Stays the same. So he's hoping that mu equals 81. Does that sort of make sense? He's hoping that the mean is the same as everybody else's. If you take my drug, your heart rate will still stay at 82. It will not change. Is everybody with me on this part? So let me ask you this. Is my claim the same as H0? Are these two the same? Mu equals 82, mu equals 82. Those are the same. Do you guys see that? So my claim is H0. That means that H1 has to be the opposite. What's the opposite of equals 82?
Doesn't equal.
Doesn't, exactly. Mu doesn't equal 82. That's the complicated one. Everything, the other two are really straightforward. So here, if your claim is H0, then H1 is just the opposite of that. It's not equal to. That's two-tailed. That's when we get the two-tailed stuff going on. Here's another situation. Mahika, can you read this one for me? Mahika, have I made you read yet?
Yeah, but I don't mind reading
Okay.
it down.
Thank you.
Situation B. A chemist invents an additive to increase the life of an automobile battery. The mean lifetime of the automobile battery without the additive is 36 months.
Great.
Claim.
Claim. What do you guys think? What's he claiming? You're the chemist. What's he claiming? He's claiming that his mean is what?
Automobile battery will be increased.
Yeah. So normally it's 36 months. He's claiming his mean is going to be what? Less than, greater than, or equal to 36?
Greater than.
Greater than. It's going to increase. Everybody with me on that part?
Yes.
Good. So now you take my additive and your battery life's going to go up. It's going to be bigger than 36. Now, the null hypothesis is always, always, always equals. So here's my null hypothesis. Mu equals 36. This number, whatever you use for this number, stays the same all the way through. 36, 36, 36. That doesn't change. Ever. You guys got that? This, whatever number you pop in here, it's going to be the same number there and the same number there. Then what's going to change is this symbol, greater than, less than, equal to, not equal to, whatever. So H0 is always equals. Are these the same? Mu is greater than 36. Is that the same as mu is equal to 36? No, they're different. So then that means that since these are not the same, one of these has to be my claim. Since H0 is not my claim, H1, I have to make that my claim. So I'm going to force H1 to be mu is greater than 36. Because my claim has to be one of them. If my claim isn't H0, then I take H1 and I make that my claim. I just say H1 is going to be my claim, whatever my claim is. Is everybody with me on this part? So this is a right-tailed hypothesis test because my H1 is greater than. All right, let's do one more. Eva, can you read for us, Eva?
Yeah.
Thank you.
A contractor wishes to lower heating bills by using a special type of installation and method. If the average of the monthly heating bills is $78, your hypotheses about heating costs with the use of installation are
Yep, thank you.
18.
Perfect. That's good.
Can you read that?
No, you're good. All right, so guys, what's my claim? My claim is my mean is what? Yeah, it should lower, right? It should be, your heating bill should become less than everybody else. Everybody else's bill is $78. Your bill is going to be less than that, lower than that. Good. So now, is my claim the same as H0? Are these the same?
No.
Nope. This one's less than, that one's equal to. They're not the same. So the H1 has to be whatever my claim is. So H1 has to be my claim. Very often, not always, but very often, my claim will be H1. Because very often, I'm trying to prove something. I'm trying to prove that my pill works, or my insulation works, or my additive works. It's not very common, not very often that I want to prove that my stuff does nothing. You take my pill, it will do nothing. That's not usually useful. And it is in that one case we saw earlier where he's trying to prove that it didn't cause a side effect. But typically, often we want to prove that we're different somehow. So usually our claim is H1, but not always. And I will always throw in one where our claim is H0, just to make sure you know how to do that as well. But this one, we're claiming that my mean is less than 78, so it's going to be left-tailed. All right, so you guys do problem number 3 on your worksheet. And again, let me change this. I'm going to say that I claim that the average age of community college students is 24.6 years. That's my claim. So you guys, write that in symbolic form using less than, greater than, equal to, or not equal to. Write down my claim, and then write down what H0 is and what H1 is, and whether it's one-tailed or two-tailed. Everyone take a minute and do that. Hey, and if Allie, if you know where Darren is, if you could get a hold of him, because I haven't seen him. And Ivana, if you have any contact with Stefan, if you can kind of check in with him too, because I haven't heard from him either. All right, so symbolic form. Let's take a look at this one. So what am I claiming? I claim that the average age, in other words, the average, the mean of community college students is, what's our symbol for is, guys? Anybody? What's the symbol for is? Equals, great. Is what? 24.6. So that is our, that's our symbolic form. You guys have questions about this one? So you take this and you turn it into symbolic form. I claim average age, the average mean is equals 24.6. H naught is always equals, so my H naught is going to be equals 24.6. So then the question comes, is my claim the same as H naught? And the answer here is yes, they are the same. So since they're the same, then H1 has to be the opposite of whether H naught is, because H1 can't be my claim, because my claim is already H naught. So H1 will become the opposite of that. What's the opposite of equals 24.6?
Not equal to.
Yeah, not equal to 24.6. Good. Well, that was really bad. Try that again. Not equal to 24.6. Is this one-tailed or two-tailed, guys?
Two-tailed.
Two-tailed, exactly. Not equal to means it could be less than or greater than, either one. So two-tailed, because it could be either less than or greater than, either one. All right, do you guys want a picture? It could be either over here or over here. All right. So here's the goal of our test. If we reject H naught, so here's the thing. What happens if you reject H naught? If H naught is my claim, then does rejecting H naught help my claim or hurt my claim? If my claim is H naught, then what does rejecting H naught do? Rejecting H naught rejects my claim because they go together. Is everybody with me? However, if H1 is my claim is H1, then rejecting H naught supports my claim. So later on, we're going to be using these words. If H naught's your claim, then you're doing the whole test to either reject or fail to reject your claim. If H1 is the claim, then you're doing the whole test to either support or fail to support your claim. And that's going to come up later. So here's this is all about wording, which gets confusing for people, so I wanted to introduce it to you early so that you can kind of get it in your head early on. So you guys all remember your ABC song, right? A, B, C, D, E, F, G, blah, 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 blah. Q, R, S, right? So Q is just to start you off. And then you have R, and then you have S. What comes first, H naught or H1? H naught. So H naught is the R, reject, and H1 is the S, support. So that's kind of how you can remember those. I totally drew that in the wrong spot. So just kind of remember that's kind of how that goes. So I want to just take a second and figure out what's the goal of each of the following. What's my goal? Am I trying to reject the claim or support the claim? So here, what's my claim? My claim was that the heart rate stays unchanged. So is my goal to eventually reject or support my claim? What am I trying to do? I mean, I'm trying to either reject or not reject my claim. Just so you guys kind of understand. Because my claim is H naught, I'm looking to either reject or not reject my claim. Reject or fail to reject claim. All right, maybe this will make it easier. Here's B. What's my claim again? My claim is Which one, H0 or H1? Okay, my claim is H1. So am I doing this whole test to try to reject my claim or not reject my claim, or support or not support my claim?
Reject.
Actually, we're trying to support. So rejecting H0 will support or fail to support my claim. So I guess the question comes down to is, what does rejecting H0 do for me? Rejecting H0 supports my claim. So I'm going to use the word support here. It's so hard to do this remotely. I wish I was with you guys. Don't worry about this. We're going to go over it more next class. But just to kind of think about this one again, give this one a shot. My claim is this one here. So rejecting H0, will rejecting H0 help my claim, support my claim, or reject my claim? Maybe I should ask you that instead. If I reject H0, will that support my claim or reject my claim? If I reject H0, it's going to support my claim. Yes, it's going to support my claim. Because rejecting H0 helps my claim, supports my claim. So here I'm doing this whole test to either support or fail to support my claim. And again, we'll go over this again next class and the class after that, and probably the class after that. So don't worry about that too much yet. We do need to focus on this part here, though. The test stat. Pretty straightforward. Test stat is the z-score for your sample. So we talked about z-scores a million times. How do you find a z-score for a sample? This one you actually already know. This one you've used before, right? But we're not going to use it here because we are not going to worry about when we actually know the when we don't know this, when we know sigma. But it's your well, this is almost like we've had x bar minus mu divided by s over square root of n. This is almost exactly what we've had before when we've found used central limit theorem problems. You guys have done this. You've taken, remember we found the sigma x bar. So you take x bar minus the mean divided by the new sigma x bar. So this is the same thing. That's no different than previous. Proportion's a little bit new. It's what you got from your sample, p hat, minus what you expected, p, or p naught, divided by square root of pq over n. And again, for this one here, it's again what you got from your sample, x bar, minus what you expect, mu, divided by s over square root of n. So these are the formulas you use. You will need those absolutely all the time. We're going to do a quick example and then have you find one. So here, Chris, can you read this? Or I'll read it quickly. We're running out of time. My bad. So we're going to consider the XORT method, which increases the likelihood of having a baby girl. Preliminary results from a test of the XORT method involved 100 couples who gave birth to 58 girls and 42 boys. Using the given claim, calculated the value of the test stat. All right, so here we are claiming that it's a proportion, right? It's a proportion of girls. What's the proportion of girls? 58 out of 100. So it's going to be, my p hat is going to be 58 out of 100. So here's my p hat. Now, we're assuming that things are the same as everybody else. So in general, what's the probability of having a girl? 50%. So that's our H0. That P is equal to 50%. The XORT says that it should increase. You'll have more girls. So it's saying with the XORT method, your proportion is going to be bigger than 50%. It's going to be larger than that. So this is my claim, H1, that our method increases your proportion, your likelihood of having a girl. What we got from our sample was 58 out of 100, 58%. So we're going to find the z-score for that. We're going to take what we got from the sample, 0.58, subtract what we expected to get, 0.5, and divide that by the standard deviation. So let's take a look at that. It's what we got from our sample, p hat 0.50 minus what we expected to get, 0.5, divided by the square root of PQ. Again, we're assuming that 0.5 is what's actually true, so we're going to use that one. 0.5 times 0.5 divided by n, 100. If you do that, you get 1.6. Now, we know previously that unusual is usually right around 2 standard deviations, so 1.6 is not unusual. So even though it may, right, because 58 is certainly larger than 50, and 1.6 is not 0, it's not even 1, it's a little bit more than that. So maybe it may increase it, but not enough to prove it, right? It's not unusual enough for us to say for sure that it changes things. So maybe it does, but we can't prove it. I need you guys to take a minute, and the last thing I want you guys to do before you sign off is find the test stat for here. Find the test stat. And then we'll go over it. So figure out what's your what do you expect, your claim. The claim is 124. So my claim is that the mean is less than 124. This is not your X bar, this is your mu naught. Whatever you have in your claim, that's your mu naught. What you get from your sample is the X bar. All right, so sample of, this is what? It's my n. Mean of 120, that's my X bar. Standard deviation of 4, that's my S. So we're going to get X bar, so that's 120. Ugh, this is terrible writing. Minus 124 divided by 4 over square root of 13. And you guys end up getting, if you did that, you end up getting about 1.6. Would you guys get 1.61 or was it 1.6? Anyone? Hey, one quick note, find the bottom part first, and then subtract this, and then divide that, because it gets messy when you start, if you put this all in at once, if you don't put parentheses around it, you get a totally wrong answer. So find the bottom part separately, and then subtract and divide. So you'll end up getting, it's like 4 over like 1.1, oh, that should be 3.6. I think it's 3.6. My bad. So you end up getting like 3.6, something in that range. And that is enough for today. Have a great day, and we will see you all on Thursday. If you can, actually, can you all just kind of check in with me before